We next look at problem C1. So this was a 3 random variable problem, and we already solved this with FORM. We will now solve it with SORM, and let's take a few seconds just to read the problem statement. There are 3 random variables y, a, and q, and their distributions are given, and we employed the full distribution transformation when we solve with FORM, and that's what we will do. We will solve the first few steps exactly as in FORM. So x1, x2, and x3 are defined as before. The limit state is x1, x2 minus x3, and we minimize the distance in the independent standard normal space U subject to h equals 0, h being the mapped limit state function, and we got the answer which is u star, as you see on the screen, negative 1.62, negative 0.65, and 1.43, and the reliability index was about 2.25, 2.26. So with this starting point, let us see how much an improvement we get if we employ SORM. So the principal curvatures of this approximate paraboloid in the remaining two coordinates are, as you see, negative 0.1564 and negative 0.04552. And how does our parabola look like? So if you can imagine, in 3 dimensions, there is a curved surface in u1 and u2, u1 tilde and u2 tilde plane, and u3 is the 3rd dimension. So that is what our parabola looks like in this rotated coordinate system, and we can now use these curvature values, this negative 0.1564 and negative 0.04552, and correct the value obtained from form. So that turns out to be, again, we have factors that increase the value of PF because we discounted we did not count some of the failure regions when we looked at FORM. So the answer turns out to be 0.01575, and if we take the inverse normal CDF, we get an equivalent beta of about 2.15. Compare that with beta of 2.26 obtained from FORM. So we see that there is a significant amount of improvement or change from first order to second order answers. But obviously, which one is correct? We did solve this problem with MCS, with Monte Carlo simulations, and the answer was an equivalent beta of about 2.15. So clearly, in this example also, an approximate second order correction almost removes all the error, and we end up with an answer that is almost the same as the accurate, the exact value.